Okay guys, so we're going to look at today substituting in some values here. So in this little question, we've been told that A is going to be 2 and B is going to be -5, and we've got a variety of expressions which we are now going to evaluate based on that. So we're just going to replace these values with what we have above, so 2 plus -5, and because we're adding directed number, in this case here, we find the difference of the two numbers, which is 3, and we keep the sign of the larger value, which is negative, so our answer is -3. In this one over here, we've got products, so we're going to put in brackets as we enter our values. So we've got 2, lots of -5, so this is going to be 4 times -5. Mix means minus, so we end up with -20 as our answer for that one. Moving on to some more interesting questions here. We've got 12 minus AB, so let's just substitute our values. In brackets here we've got 2, and then we've got in brackets -5. So this is 12 subtract, again mix means minus, -10. And we can, when we're subtracting direct number, we simply add its opposite. So this is plus +10. 12 plus +10 is 22. In this example over here, we are going to, again, we put A in, and A is 2. It's going to be squared, and then we're going to take away 2. So we've got 2 times 2, which is 4. Take away 2 will give us with the answer 2. It would have been a bit more interesting if B was -5 in there, but let's go ahead and do this one first, and then I'll give that one a crack. In this question here, we've got B becoming -5 out the front, and then we've got 2 minus 4. Let's evaluate what's inside the brackets here first. So we've got -5 times -2, and -5 times -2 is 10. Just jumping back to this question over here, if we had b squared minus 2 in this case, and then we substituted in -5 squared minus 2, you've got to be really careful in this type of example. Make sure you keep your brackets with your substituting, because if you were doing 5 times 5 for 5 squared and just had the negative symbol at the front, you'd have a -25, and you'd end up with the wrong answer. In this case, -5 times -5 is 25, take away 2, and the answer is 23, as opposed to if you got it wrong, you might end up at -27. Alright guys, in these questions we're being asked to simplify by gathering like terms or collecting like terms. The first thing you need to kind of get your head around before you start doing these ones is to understand that D is a number. It's a number of things, and I like to give myself a little bit of a story. In this case here, I might decide that D is, it's going to be a number of things, so that it's going to be the number of donuts that I have in a box. I've got no idea how much is in that box, but over here I've got a pile, I've got 4 lots of those donuts, and over here I've got 3 lots of those donuts. Now the most important things are those things are exactly the same amount. Okay, so if I had 4 boxes over here and 3 boxes of them over here, then quite clearly I've got a total of 7 boxes of donuts all up. Now over in this case I've got 3 more boxes of donuts, and they're being added to something else, and I'm going to say, well, probably don't need any more donuts, so let's say these are bags of apples in this case. Okay, so I've got 5 bags of apples, and then something else is happening over here to 4 bags of apples. Now, there's not really any relationship that I can have between my donuts and my apples if I try to add them together. It's not like I've got 8 box bags of donut apples. They're 2 separate things. So I can't really add those together. So this has to stay here by itself. Over on this side, I've got 5 bags of apples, and I'm losing or being subtracted by 4 bags of apples. So if I had 5 and I lost 4, clearly I've just got 1 left. And in maths, we just don't bother writing that 1. We just say, there's a bag of apples. If we continue along, something a little bit different is happening here. Okay, we've got x and y together in this case because they've been multiplied, okay, not added like we're trying to do over here. We can't add those together. But when things are multiplied, well, that's like saying I've got a rectangle which is x long and y high, and it makes this shape. Now this is telling me that I've got 2 of those, and this is telling me I've got another 7 of those. So you can probably work out that if I've got 2 of these xy's and I've got 7 xy's over here, altogether I've got 9 xy's. When we come over here and look at this question, it's a little bit different in this case. What's different about this one here is I've got 12t squareds and I'm adding 3t's to it. Now I can't really add, if I've got a t square here, I can't really add just a t to it because this is about the space that this makes up, and it doesn't really make any sense putting a length into a space, for example. So we can't actually add these terms together. What we can do is we can use the commutative law, which allows us to move addition around, because addition can be done in any order. So I'm going to leave this first term as it is, and I'm going to move this term, which I see is a t squared, I'm going to move it further up the list. Okay, and you can see here I've got 12t squared plus 3t squared, so I'm going to be able to do that. This, I can't just ignore it, so it has to come along still, and quite nicely on the end here, you can see I've got 3 t's, I'm going to lose 1 t on the end there. So similar to what we did at the beginning, in the previous exercise, this and this are 2 different things, just as this and this are 2 different things. Okay, so I can gather these ones here, and that will give me 15t squared, and over here I can subtract 1 of those 3 t's, and I'm left with just 2 t's, and that's of course being added. It's really important to realize that you can't just make that t. If you've got 3t, take away t, the answer is not just 3. Okay, because this is saying 3 lots of t. I've got 3 lots of t, and I'm taking away 1 of those t's. All right, just to finish off with these last 2. So far we've been doing addition with these terms having a bit of multiplication in them, which we've used as repeated addition. In this case here, there's actually no addition at all. We've got 7 lots of d, and we're multiplying that by 6. So that's like saying I've got those 7 boxes of donuts, and I've stacked that pile of 7 boxes 6 high, and I've got way too many donuts at the moment. What we can actually do is we can use the commutative law for multiplication, because there's a tiny little multiplication between these 2 which we don't even bother writing, and we are able to move a multiplication around because it does not matter which order we do multiplication. In this case here, I've got 42 lots of d, which I said way too many. Over here I'm doing a bit of a division. In this case, the vinculum here suggests that the top numbers are being divided by the bottom numbers. And if you take a little look on the end here, I've got b over b being divided. Okay, and if you have any number and you divide it by that number, we just get 1. So in mathematics, we cancel when anything like that happens. In this example, on this side of the question, I've got 11, and you probably realized that 44 actually has 11 as a factor. This is 11 times 4. So again, 11 would be on the bottom, 11 would be on the top. So I'm going to picture that in my head, cancel out the 11s, and then realize here that there's 4 remaining. All of these other ones that were cancelled, they just become 1. So on the top, I've got 1 times a times 1, and we just write that as a. And on the bottom, I've got 4 times 1, and that's it. So we just got 4. So my answer is a on 4, which you might also realize is actually a quarter of a.